Hi, everybody. This is the Hungry Math Professor here. Thank you for coming to my channel. And today I'm going to discuss lectures on the foundations of mathematics by Ludwig Wittgenstein. For those of you who are paying attention to the channel, I've been on a Wittgenstein kick lately, and so there'll be more of this to come. But this one was particularly interesting for me because so it's not really a book in the traditional sense. This was a series of lectures given by Wittgenstein in Cambridge in 1939. And the way it became a book is that like four of his students who attended these lectures made very detailed notes. And this was edited by Cora Diamond, who took those notes and kind of triangulated them into one book, right? So there's many times throughout this book, which is broken up into a series of lectures, which you can think of as chapters, where there's an asterisk saying like all four of the notes disagreed quite, wildly about this particular sentence, and so it could have been translated differently. But it seems like there was enough, continuity between the four versions of the notes for Cora to put this together into a book where most of the degree agrees. But at times, I think they had to make some choices about what the sentences were. So it's interesting. It reads though fairly well, I would say. I find it quite understandable, and it's interesting because at times it really fills in some of what Wittgenstein is thinking about in the philosophical investigations. So if you enjoyed the philosophical investigations, I would sit and you want to understand a little bit more of what he's trying to say about math and logic, then I would say check this out because it will give you, I think, even more insight into some of the things that Wittgenstein's saying in the philosophical investigations. Of course, in the philosophical investigations, he often he doesn't always like introduce the ideas with a lot of context. So some of the mathematical examples that he gives sometimes feel confusing because you just don't understand exactly where he's trying to go with this. And so I would say that reading this lectures on foundations of mathematics will only fill in some of what he's trying to say in philosophical investigations. It's also interesting how some of the things are exactly the same, right? But in this book, they're written more conversationally instead of like in this aphorisms form. But it still feels like Wittgenstein. He's still like asking a lot of questions and being skeptical and breaking things apart quite a bit. So that's interesting. And another thing that's interesting is that Alan Turing was in attendance of these lectures. And so throughout, you will see Alan Turing asking questions. Like in the book, he'll say Alan Turing and then a question. And Wittgenstein and Turing are going back and forth. And oftentimes there's a little bit of tension there where they're trying to challenge each other on certain points, which is interesting. So there's 31 lectures in total in this. I will say they are a little bit slow to develop. I would say I really started to love this book around lecture 15. Lecture 15 was one of my favorites. And, the first 14 or so, it was a little slow. And it's funny because even at the end of some of the lectures, Wittgenstein will admit, like, I meant to get further than this, or I wanted to talk about this and I didn't get a chance to. Or sometimes he'll admit, like, I didn't really say this very well, So I like the candor in his lectures. And famously, he would come to his lectures and he wouldn't have notes. He would just kind of speak off the top of his head, and he would make long pauses as he thought about things, and he would ask questions to the crowd. And so it's quite a different form of lecture than what we tend to think of. But I also think it must have been quite exciting to be in attendance in these kinds of things if you're interested in this topic. But the reading for me definitely was a bit slow and maybe not completely drawing me in until like lecture 15. But because I'm already like having this very deep interest in Wittgenstein right now, I really wanted to keep pressing on. So, what are some of the things that Wittgenstein is talking about here in the lectures on the foundations of mathematics? I think it's important to remember the time period that we're in. Um, it's so this is written, or these lectures occurred in 1939. We're coming out of a period where, Hilbert's project to try to establish a solid foundation for mathematics that's complete, consistent, and decidable. That has been broken to some degree by Gödel's incompleteness theorem. That's already happened before these lectures, but I think it's probably still in the air to some degree. This idea that like math is about objective truth is something that Wittgenstein wants to respond to. Whether math is invented or discovered, the sort of Platonism about math that he wants to discuss. Remember, set theory is being established and being debated philosophically, and what are the right axioms. There's logicism by Frege and Russell, the Principia Mathematica by Russell and Whitehead, that are attempting to establish mathematics as an outpouring of logic, which is a little bit different than how we do it now, where we use logic as like some foundational language, and then we pick axioms in logic that define ZFC set theory, which then defines mathematics. That's at least one way of thinking about it. But we have a very clean separation between logic and mathematics, at least in the modern view of things. But Wittgenstein is partly responding to this idea that math is just an outpouring of logic, and specifically, he talks a lot about Russell's ideas, which makes sense because he was a student of Russell, though he definitely diverges quite a bit from Russell. And he also criticizes G.H. Hardy, or brings up G.H. Hardy's views quite a bit and criticizes them. I remember G.H. Hardy is the one who wrote A Mathematician's Apology, which I did a video discussion of. And so it's interesting, how many of these people are in the air. But to get to more into Wittgenstein's point of view that he's representing, this idea of whether math is invented or discovered, Wittgenstein comes very firmly down on the side of invented. He's in the investigations, it's hard to ever pinpoint him on like any particular very firm view about things, except for things about language games and family resemblances, the definition of words and things like that. But he rarely comes down with like a very distinct philosophical view. But I would say here he's definitely coming down on the side of math being invented. He does not think math is discovered, right? He doesn't want to say that math is he asks questions like, the Platonist view that Hardy tends to represent. He asks questions like, what would it, in mathematics, we ask like, oh, there must be some underlying being to these mathematical truths that causes them to be true. And he asks these questions like, what does that even mean? Like, what are we talking about? And again, it's very Wittgenstein in a sense. It's like, how are we misusing language here? And for Wittgenstein, although he's never really an empiricist, you can kind of see why the logical positivists got confused a little bit with what Wittgenstein is saying, because Wittgenstein is always trying to point to things we can measure in the world. And so that's very like empirical, right? Though he doesn't ever make like a full empiricist move to try to like create some kind of empiricist philosophy per se, but it's very pragmatic in the sense of like the only thing that we can use to measure our what we're saying and how useful what we're saying is something in the world, right? And he's constantly in these lectures saying, you can say that mathematics is about something we see in the world. It's about, finding the area of rectangles, or it's about like creating these arrays of people, and that's what multiplication is, put 8 people this, or put 8 dots this way, 5 dots this way, and then count the number of dots. That's what multiplication is. He's like, you can say those things, but and it's not so much that it's untrue, but he says, do you ever carry that out and use these diagrams to figure out what all multiplications are? No, you use it as a way of teaching people, and there's nothing wrong with that. But mathematics is not about like that thing that you can do in the empirical world, which is create these arrays of dots and then constantly making more and more arrays of dots to figure out what multiplication is, right? He's like, that's not what mathematics does. I've only ever done it for like small numbers, 3 times 5 or 5 times 9, and it's a useful human thing to help us learn, but we don't do these empirical experiments to decide what the facts of mathematics are. we always generalize and abstract and create rules. And that's all we can do, right? Because we can't physically multiply all these multiplications out. But he's constantly pointing this out to you in many different ways, in many different examples that like mathematics is invented. It's in a language that's invented. And be very clear, Wittgenstein is very, I think he's like, it's useful. He's not trying to say mathematics is not useful. He's not trying to say we shouldn't do mathematics. He's just trying to say, he's trying to open our eyes to the fact that it's just invented. It's an invented language, right? And it's useful because we can apply it to certain things in the world. Um, but it really depends on what thing we're trying to apply it to, what mathematics we use, right? Like which of the invented languages or invented structures we use depends on what we're trying to study in the world. And so he's constantly trying to point us to the fact that mathematics is invented and we should not expect it to be objective truth. We should not expect there to be some platonic world that realizes these truths. He's like, why do you think that has to be the case anyway? You're just taking what you're used to in the physical world, right? When you study the physical world, you're like, yeah, there are things out there that I can measure which make the things I'm saying true. And he's saying you taking that idea that you have that's very clear to you, and then you're like projecting it onto this abstract world of mathematics. And why are you doing that? Right? You're confusing terms, right? This is where it's very Wittgenstein, right? He's constantly saying that we're abusing language. He constantly wants to point that out in the philosophical investigations and in uncertainty as well. And this is no different. He keeps trying to point out the ways in which we misuse language or take a metaphor when it comes to like studying the empirical world, and then project that metaphor onto mathematics and things like that. You say, why do that? That's a mistake. You've made a mistake. You've created conceptual confusion when you do that. And so, I must say, I find him quite convincing in this way. I think the way I'm thinking about it is like, as a mathematician myself, there's something very poetic and beautiful about while I'm doing mathematics, feeling as if there are objects behind this which make it true. And there's something human about that. And I don't think as a experience, I'm not so sure that that's a bad thing. But that experience of feeling like there are objects behind my mathematics does not make that true, does not make it something that's grounded on some kind of evidence or anything like this. It's just something that feels good as a human being. And again, I don't think there's anything particularly wrong with that. But it reminds me of this saying that mathematicians are, formalists during the week and Platonists on the weekend, or Platonists on Sunday, or something like this. That we kind of slip in and out of. We want to be Platonists when it just kind of feels good when we're doing research to like poetically talk about these mathematical objects and what they mean. It's very enjoyable, I think, to talk about mathematics that way if you're somebody who does mathematics and interacts with these things. But then when pressed, by like some kind of philosophical questions or something, then we're like, we'll retreat to formalism, say, well, it's just we pick some axioms and we pick logic and we do these things on top of it, and we're willing to kind of retreat to that kind of formalism. And I think Wittgenstein is what I like about what he's saying is he's saying, yeah, these math is a language. It's useful. It is in some sense a formal system. He doesn't use that word, but I think that's the way I would say it now. But that shouldn't make it any less, it doesn't make it any less useful or important. We shouldn't feel like that cheapens it. But that's me talking. But, so we don't need there to be this platonic realm for it to be beautiful, right? I think that's how I think about what's going on here. Um, and at times, Wittgenstein seems like he's almost representing a finitist point of view. And I just want to be very clear, he's definitely not a finitist. In fact, at certain points in these lectures, he's explicit about saying that finitism is ridiculous. He thinks it's silly. And so clearly he's not a finitist, but he does get a little confusing sometimes because sometimes it seems like he's saying that like, because he's very skeptical of rule following in general. Like when we lay down rules of addition or multiplication, we only ever do that. We only ever do examples of that for like small numbers. And then we say things like, well, you can continue this process and we can multiply any numbers, and that always feels reasonable to me. His point, and this is true in philosophical investigations as well, he's very skeptical of this sort of rule following thing that like we're all going to agree when we multiply super large numbers. How do we know that we're going to agree? We haven't actually laid down the definition of these things. There's no Platonic realm that causes us to agree, and it's not about the physical world. So there's no reason to think that we're going to agree about how this rule goes on, dot, 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 as we go on towards infinity. He's very skeptical of that. At times, I will admit that skepticism about rule following is hard for me to buy into. Sometimes I'm really convinced by it. Other times it's hard because he's talking about like just even adding one, right? One, two, three, four. We assume that if we continue doing this, we'll all agree. And he's very skeptical about this. He's like, why do you say that? Like maybe someone counts by one all the way up to 100 billion and then starts counting by two. And who's to say that that's wrong? All you've ever taught them how to do is to count by one up to, I don't know, the most I've ever counted up to maybe 200 is, I'm not sure if I've ever done that consecutively. So he's very skeptical of this sort of rule followings. And this is, again, also very present in philosophical investigations. At times I find this hard to swallow because maybe it's because I've just been a mathematician for so long. This idea of adding one just feels so possible. Like it just I'm so convinced by this, right? But I also like it because I like philosophy in the sense that I think philosophy's goal is to point you to the assumptions that you make and ask you, are you sure about this assumption? That's how I see philosophy. And so I even though I'm have a hard time swallowing at times some of his skepticism, I want him to push me there because I just want to question even those deepest held assumptions. Like, is that really, should it be held as deeply as I hold it? So, I would encourage you to, go down that road with Wittgenstein and challenge him. You can't challenge him as a person at this point, but challenge the ideas, but also try to see what he's saying, right? And I think I've already said this a little bit, but he's constantly trying to separate the mathematical from the empirical. And I think he's trying to say that, like, at times, if people press us a certain way philosophically, mathematicians will start pointing to things in the world as examples of mathematics. And he's trying to point out that, yes, those are examples of how we use mathematics to study the empirical world. But he's constantly trying to separate those two things and remind us that we never use the empirical world to define the entire rule of mathematics or define how mathematics works. So you can't really use the empirical world as like a justification for how things are done in mathematics. And he's constantly trying to do that. He fundamentally rejects foundationalism, this idea that we can establish some firm foundation for mathematics that will, make it clear that math is objective truth or something like that. He is very skeptical of this. He's constantly criticizing Russell and Frege for their logicism. And he brings up points like, Russell will establish, what arithmetic is out of logic via these symbols. That's great and all, but does that actually give you any more certainty or any more reassurance that these things are correct? Just because Russell can give you some formal, like, formal strings of symbols that are representing arithmetic following from some logical foundation that he gave, does that really make you any more certain of these arithmetic facts? Or are you just kind of reverse engineering some system to make you feel better, right? Like, what is it? You already seem to think that addition and multiplication are completely well-defined, useful things. Why do you feel like you need to provide this system that undergirds it? It doesn't make it any more solid than it was before, right? I think is his point. Again, you should read it because it gets more nuanced at times than what I'm saying, but I think that's his big point. And I think that's true. I think in a lot of ways, math has, I think, taken that to heart, maybe not from Wittgenstein, but I don't think mathematicians, for the most part, we don't really study ZFC set theory. We definitely study set theory, but we study set theory as like a useful language that we all need to use. And I think you could probably get some mathematicians to say that ZFC is the foundation for mathematics. But I think most of us are not really foundationalists in any kind of strict philosophical sense. I mean, the way I think about ZFC now is it's a tool for organizing the community around what mathematics is, right? So it's not so much that ZFC or any of these foundations create some kind of legitimacy to mathematics, but what it does is it coordinates our language. It coordinates our subject in some way. And that's useful, right? It also makes it so that we can formalize mathematics on computers. Like all this language being formalized into one system doesn't mean that we've made mathematics objective per se, but it means that we can program computers to speak this language, right? Because we formalized it enough. And so that doesn't necessarily mean progress necessarily, but it's interesting. So also like some of Wittgenstein's rule following skepticism is interesting to think about in the case of computers and the case of formal systems checking mathematics. I assume Wittgenstein would say something like, why do you trust the computer when it says that something is true? Why do you trust the computer more than you trust humans? Are you sure that it's following the rules the way that you want it to? I mean, pragmatically, we can just say, well, it gives us a certain, higher level of trust or something like that. But I think he would have some rule following skepticism about formal systems, because he's pretty hardcore about being skeptical of that kind of thing. And then, something else is he's critical of this idea that logic is self-evident, that the axioms of logic can be said to be self-evident. It's like, these are just axioms that you've picked and they're useful and that's fine, but these are not somehow self-evident truths. Like, what does that even mean? Right? And I want to say, like, I think this idea of a self-evident truth is extremely unsatisfying. I mean, I get why we go there, but it just doesn't make sense. Like, if I have to declare something to be a self-evident truth, that's not really what I wanted from truth, right? It doesn't really feel like it makes it any more objective or any more solid just to say self-evident truth, right? Again, it's useful to codify what we call standard logic and the axioms of set theory and things like that as a way of coordinating the community around a particular language. That's extremely useful, and I think there's a good reason why we've done that. And I don't think Wittgenstein is even critical of that sort of thing. He's just critical of the idea that somehow means we've created some kind of truth or we've established, some kind of certainty or something like that. That's just not the case. And, now there are many different kinds of logic, not that mathematicians use for the most part, but there are many different kinds of logics out there. Some are more useful for certain kinds of philosophical situations, but people are building mathematics on top of intuitionism is the famous one, though it's never gotten that popular. But there are other things out there which are interesting, and there's this like pluralism in mathematics, famously by Graham Priest at the CUNY Graduate Center. And I'm very sympathetic to these kinds of points of view because I do think that math is a language, and I do think that there are many different ways that we can choose to define logic and define mathematics on top of logic. And the real test is whether it's useful. Like, and useful can mean lots of different things, but the point is, what are the useful choices for us? Right? And if you think about what does self-evident truth really mean, I think the reason why it can become satisfying is if we can get enough people to agree with us, right? Again, it comes down to persuasion in some sense. If we can find enough mathematicians or logicians that agree about the foundational axioms, we can form a community of people who feel similarly, and then it can start to feel like truth because we agree enough about these ideas. And I'll end on this one example, which I really like, where Wittgenstein taught, this is in lecture 15, one of my favorites. He makes an analogy to chemistry. He's like, in chemistry, you can have this conceptualization where you can talk about chemical bonds, right? And you can talk about, H2O and all these different things. And he points out, I should look at this specific example because I don't know chemistry very well. He points out to this idea that H2O4 and this may have changed, so sorry if the chemistry is not correct anymore, but he talks about how H2O4 is completely possible from the conceptual framework of chemistry. There's no like contradiction in this idea of H2O4, but they don't observe it in the world, right? It doesn't seem to observe. And what I think he's pointing out here is like there's a separation between the conceptualization of chemistry, which is like this language and this that we've built, this language game, if you will, to use Wittgenstein, that we've built to understand the world and understand specifically chemistry and these things about the world. But that doesn't mean that everything that that conceptualization predicts or allows for, like something like H2O4, is actually telling us something about the world. And chemists can choose to believe that, oh, there must be H2O4 somewhere in the universe, since they can make all these kinds of claims, but that doesn't mean um, they could be mixing up the conceptualization, the language that we use, and the way the world actually is, right? And they could be giving too much credit to this conceptualization, and perhaps it's just some kind of useful approximation, and maybe H2O4 is actually a contradiction or never will be possible for reasons which our current paradigm doesn't, point to. And part of what I think he's pointing to here is that um, this is how mathematics works all the time. Like mathematics is not telling you what's possible in the world. It's just coming up with, I'm going to use the word interesting or useful languages that are appealing to mathematicians that we find beautiful and and they may never some of these things may never say anything about the world around us, and it doesn't mean that there has to be some like platonic realm where these things are real either, right? It's just something about the structure appeals to mathematicians, and that's enough, right? But don't confuse that with some kind of objective reality somewhere, right? He's very critical of this sort of Platonic idea, which I do appreciate. So I do highly recommend this, especially if you're following my Wittgenstein readings and becoming sucked into his ideas. And I would highly recommend this as like a going even deeper. And it is really interesting to see some of the ideas in the philosophical investigations fleshed out in a different way, like not in this aphorism style. And it's also interesting just to see Alan Turing like going back and forth with Wittgenstein. So check it out. Let me know what you think. Like, comment, and subscribe. And I hope to see you at another video.